The X-ray diffraction analysis is an ideal case enables one to locate to each atom protein molecule. Study of scattering light and X-ray which furnishes data on shapes of globules. As you can see in this diagram that the particle optical spectrometry (NMR) or EPR gives information on fraction of residues present in alpha helical, cross, beta and disordered forms of their interaction and mobility, etc. Electrophoresis. Electrophoresis in this we study on charge on globules. Study of deuterium exchange. As we know that deuterium is isotope of hydrogen. It estimates the fraction of residues linked by the hydrogen bond and to identify internal and external atomic groups in protein. And also the study of denaturation and proteolysis. It aims data on stability of globules, information of calorimetry, especially important. Diffraction maxima of various intensities. Analysis of diffraction patterns enable to one to design electron density distribution to inner crystals. The electron density is expressed through a so-called structure amplitude, which depends on number of electrons in and on direction of scattering. Structure amplitudes are complex quantities characterized by the module and phase. Without knowing the phases, it is impossible to establish the structure of the material. The heavy atom, which has many electrons and which strongly scatters X-ray, brings out applicable changes in intensity of diffraction spot. The phase of diffraction spot from difference in amplitude is present in the absence of heavy atoms. The use of protein derivatives containing several heavy atoms allow one to solve the phase problem. This method is method of isomorphism. The 40s of the century of the X-ray diffraction patterns of relatively simple low molecular weight compound confirm their structure established by chemical method and provide quantitative information interatomic distance. In 1944, before the 40s of the century of X-ray diffraction patterns of relatively simple low molecular weight compound confirm their structure established by chemist method and provide quantitative information on interatomic distance. In 1944, the structure of penicillin, which could not be determined by the chemist, a molecule of penicillin contains 23 atoms other than the hydrogen bond. Further, Hawking established the structure of vitamin B12 having determined coordinate as many as 93 atoms. Later, the X-ray diffraction technique was employed in investigation of protein, the most complex molecule. The founder of this trend in molecular biophysics was J.D. Bernal. The greatest achievement in study of biopolymer is due to the Cambridge Research School. In 1957, John C. Kendrew solved the spatial structure of first of the protein analyzed myoglobin, having located in the position of its 2500 atoms. You can see in figure 5.4 the spatial distribution of electron density in myoglobin is given here. At present, high-resolution X-ray diffraction has been carried out for about 150 globular protein. Mention should be made here. For example, the interpretation of structure of peptide like hemoglobin, aspartate aminotransferase. A number of enzymes has been studied. The structure of complex formed by enzymes with inhibitors and with analogs of substrate has been elucidated in some cases. The fundamental problem of the phase is the X-ray diffraction of protein is as follows that the structure of protein molecule in crystals coincide with the biological function structure in aqueous solution or not. Here in this given two figures 5.5 and 5.6, the X-ray pattern of the sodium salt of DNA is crystalline A form is given in figure 5.5. You can see how it looks. And next figure, the Debye photograph of collagen is given. Just you can see it.